Based on what we did yesterday and factoring each of these on that assignment, what I would like to do is take it one step further now, and I want you to set all of these equations that we have here, I want you to put them equal to 0. Just write equals 0 next to them. Okay, and let's just start with the top row so we're not going through all of them like that. Okay, I think the top row will kind of give us what we need. Okay, we set them all equal to 0. Okay, the whole point of factoring, at least right now for us, is so that we can solve for our variable. And usually the variable's x. Okay, I know there's different letters on this page, but usually we're dealing with x here. But it could be any quadratic. So we have all this now, and we've said equals 0. Okay, and that means this is also going to equal 0. And this is also now going to equal 0. Just a really quick review. Yesterday, we said that standard form was y equals ax squared plus bx plus c. Remember, we had identified the a, b, and c. Well, we really didn't talk about what y does. If you think of an equation that we graph and think back to just linear equations, you had y equals mx plus b, you get a straight line across the x and y axis. You'd be able to input something for x and solve for y. Well, the same thing's true with quadratics. You can input a value for x and get an output of y. A quadratic would be
curvy.
Well, a quadratic, makes a U shape. Okay, it's called a parabola. And that parabola hits the x-axis. It could hit it in 2 spots. It could actually hit it in 1 spot. It could hit it in no spots.
That'd be a very...
If your parabola hits in 2 spots, you have 2 solutions. Those 2 solutions are what you're finding right here. Notice we don't have equals y, we have equals 0. So if I rewrote this and said, okay, I'm not going to make y, I'm going to say y equals 0. If you're looking at a graph and you're saying y equals 0, okay, that y equals 0, right? Tell me when.
Right there. Up, up, up. Right there.
Right there. And notice y equals 0. When y equals 0, that's where you cross the x-axis. That's why we put 0 in for y. When we plug 0 in for y, we can solve for x. And so that's why all these will say equals 0. You want it to equal 0, because then you're finding where it's crossing the x-axis. So just like we did in the lesson a couple days ago, when we had 2 things multiplied together, just like we do here, when you have 2 things multiplied together and they equal 0, one of those 2 things has to be 0. So what would make x plus 1 equal 0?
Negative 1.
Negative 1 would. That'd mean x would have to be negative 1. That's one of your answers. You've now solved for x. So you've taken a step farther. You've factored, which is what we did last night, and now solved. Okay, I want everyone to set this equal to 0. And solve for x. Some of you are really good about just being able to say the 2 steps. What are the 2 steps?
Subtract 2, divide by 3.
If we subtract 2 from both sides, we get that. And then we divide by 3. When we divide by 3, we get that. You could just state the 2 steps. I subtract 2 and divide by 3. That's your answer. Okay? Those are my 2 solutions. That means this graph crosses at negative 1 and negative 2/3. Now we're not really worrying about the graph. That's next chapter. Okay? But right now, I just want you to be able to relate these things. Trying to relate everything you're doing here will help you remember it better. Mm-hmm. We learned this to begin with and solved. We then learned how to get to this. We now have put the 0 in so we can find these, and we know what they mean, which is what we're going to do next chapter. That's kind of where we're going with it. Thank you. Okay? All right, I want everyone to, on number 2, figure out what x equals. Okay? Find what x equals, and then once you're done and your neighbor's done, compare with them. So one of our answers is -2. The other answer is subtract 1, divide by 3. So once you factored, is that last step hard? Not too tough. Okay? That's all we've got. Sarah? You can just do what I just did there. I assume you can do a 2-step in your head like that. Okay? So if you had this, if you put -2 and -1/3 as your answer right below it, I would know that you've got it. Okay? All right. Guys, that's what we're doing today. Okay? So while I'm passing out this assignment, I want you to tell your neighbors which problems are the easiest on the first, out of the first 6, which ones are the easiest ones and why. Everyone should have their assignment. A couple things to talk to you about. First, which ones are easiest and why? Raise your hand, please. Out of those first 6. Cassie. Okay. Okay, so the ones like here we have a 4, here we don't. Okay, so those look easier. How about these 2 compared to these 2? Which are easier? The 3 and 4 or 5 and 6? 3 and 4. Why are these easier than those 2? Good. These are already factored, right? When they're already factored, all you have to do is go, yep, my answer is -1 and 5. I am done. Okay, you should probably put k equals. Okay? But really, that's it. It's that simple when they're factored and they equal 0. Now, that's a key thing. It has to say equals 0 because look at number 5. Does number 5 say equals 0? No, and it's not factored. So 2 things. First, you have to set it equal to 0. How do we get that equal to 0? Yeah, start by adding 5. Just move the 5 over. We add 5, we get 24. And now it equals 0. That's the first step. So if you are someone who needs steps, write it down. Sorry, thank you. First step, set equal to 0. Okay? Second step, after we set it equal to 0, what should we do to it? Yeah, find A, B, and C. We're going through the process of factoring. Factor. And if you're like, factor, that vocab term, I kind of remember, I get it. Just remember, factor means this. You're making your parentheses. You're factoring. You're pulling out the factors of it. The greatest common factor if you have to. Okay? In this case, our A, B, and C is our first step. And notice A, Tyler, this is what we did yesterday, Ty. Notice A is what? 1. B is, and C. When A is 1, it's really easy. A lot easier than when A isn't 1. Yesterday, A was never 1. Today, A is 1. The benefit when A is 1, when you're doing your diamond, right? You're saying, okay, A times C. Well, it's really just C, right? Because A is 1. And then B is down here. You're saying what 2 things multiply to make 24 and add to -11? 1 times 24? No. 2 times 12? No. What? -8 and -3? Yeah, that works. Those 2 multiply to that, and they add to that. That's the diamond there. Okay. It's kind of messy. All right, so that's what goes in here. X minus 8, X minus 3. What was the last step we had yesterday? Divide by A. But once again, A is 1. So if I divide by 1, does it change? No. So you got, if you haven't made this connection, you will really like the ones when A is 1. Because it's very easy. When you do A times C, it's just C. When you divide by A, it's still the same thing. Just don't forget to divide by A. So my answer here is x equals 8 and 3. So that is putting it all together now. Okay. Now, one thing we haven't talked about is you'll see this notation sometimes. They put like squiggly little brackets. That's called set notation. That just means the answer is 8 and 3. Okay. So if you want to get in the habit of writing that, that's actually the mathematically correct notation. Is it serious? Okay. Yeah, 6, 7, and 8 also A are 1. Yeah. So remember on number 9, the difference. Let's do number 9 together. Okay? Do your first thing. Actually, I'm going to finish my list here so you guys know. Okay? Solve for x. Or whatever letter we're using. I'm going to use x as my general. That's the last piece. Okay? So give number 9 a go.
Find A, B, and C.
Good. Tell your neighbor the first step is not to find A, B, and C, though. What do we have to do first?
Read the problem.
Yeah, set it equal to 0, right? So we got to move 6 over. That gives us 6n squared minus 18n. If I subtract 6 over, what do I get? Come on, man. Negative 24. Some of you are working away. I'm trying to keep you from making the mistake that you're about to make. How many of you are doing the x right there now? Okay, you have to. There's one piece in here that we have a problem with. What goes into? Yeah, who said it? Yeah, what'd you say? Yeah, you could take a 6 out of all these. So you factor out a 6. 6 times what is 6n squared? Nope.
6.
6 times what makes you that?
6n.
Just n squared. 6 times what is negative 18?
3n.
Negative 3n. And 6 times what is negative 24?
I don't understand what's going on, but I'll ask that.
Okay. So you really are just pulling out the greatest common factor. How many remember doing that earlier this chapter? Trying to put everything together here. So if you skipped any of those lessons, it'd be a little tougher. Okay? Pull out that 6 because 6 goes into 6, 18, and 24. And now the part that you're factoring, you have 6 times, you have two things that you're multiplying together. You're multiplying 6 and you're multiplying that. Can 6 ever equal 0? No, it's not going to transform and become a 0.
It's not?
Therefore, this part, when we're solving, we don't really care about. It's not going to affect us in any way. However, this part, if you're using your diamond, you're making negative 4 and you're adding to negative 3. Two things that multiply to make negative 4 and add to negative 3.
What? Negative 4. 4 negative.
Yeah.
Good. The 6 can just be along for the ride.
Okay, I get it now.
What are our answers?
Let's see. 6. N equals 4 and n equals negative 1.
Does n equal 6?
No.
No, there's no n out here. The 6 is just along for the ride. So that's n equals 4 and negative 1.
The 6 is the hitchhiker.
Don't pick up hitchhikers. All right. Danger. Okay, please note there's front and the back. Okay, do your best at this. Okay.
I'll try to.
All right, make sure you're asking for help if you need it. Okay, the answers are on the board. Hey, I want to just really quick on number 10 since I've had two pretty bright students make the same mistake. So let's make sure that on this one we're clear here. This right here, you add 7 over. When you add 7 over, you get 7r squared. Negative 7 or negative 14r plus 7, you cannot put those together because one's r's, one's counting r's, one's counting units. So you just write it as negative 14r and plus 7 equals 0. And now from there, you do your factoring. Oh, thank you. Thank you for pointing that out. From there, you do your factoring. Okay? Good call. Are there any other problems that I can touch on while I'm up here? Not all. Can't go all of them.
I don't have it.
Number 2.
Got my USB.
Oh.
Here.
Hey, so 22, if you're setting that one equal to 0,
you can have this in compensation.
you got a minus 3 and add 7a to both sides. What can I put together? Days. So this gives you 0, that gives you 0. So now you have that. Right?
Yes.
Then divide by your A term.
Do they really? There's a fact.
That reduces to 1/3. 3 goes into that 3 and 5.
Oh. We're out in 1 minute.
And what?
1 minute. I should modify that. Seconds.
It's supposed to be negative 3/5. Ran out of room there.